plank, you will move 3L by 4 one person, and the other person, person 2, he will walk 2L by 3. So we have to calculate with this, find the displacement of plank here. So you can draw a diagram, check it. So I think I'll directly go for a method. What is that? M1 delta x1 plus M2 delta x2 plus M3 delta x3. Put it. Because as the person walk, there'll be friction acting like this. F1, F1. This person will walk F2. This will be F2. So F1 may not be equal to F2, or F2 may not be, or F1 greater than F2, or F1 will be less than F2. Or F1 may be equal to F2. We don't know altogether. We can't get into that particular analysis here. So directly I want displacement of Planck. I'll use this formula. Now what is delta x1? Displacement of person 1 with respect to ground. We don't know that. We'll calculate like this. Displacement of person with respect to Planck. 3 means Planck here. 1 means person 1. Should be equal to x1 minus x3. These are with respect to ground. This is displacement of person 1 with respect to Planck. With respect to Planck, how much? Anything towards right? Positive. 3L by 4 plus 3L by 4. Do we know displacement of person? We don't know. Leave it. Don't put any sign. The unknown things, don't put any sign. Then we don't know displacement of Planck also. Leave it. Let's come for second person. x23 equal to x2 minus x3. Displacement of second person with respect to Planck. What action second person will move towards left, no? So minus 2L by 3. Why negative sign? Because displacement of second person is towards left is equal to displacement of person with respect to ground. We don't know. Displacement of Planck with respect to ground. We don't know. So what is x1? x1 equal to 3L by 4 plus x3. What is x2? x3 minus 2L by 3. And what is delta x1? Call now this is delta x1. Fine. Call this is delta x2. And what is delta x3? Should be equal to x3. Substitute, I think we know all the values. Substituting this, M1. This is the approach which you have to develop for exam, because time will be very less. No, you can't draw all the diagrams. No? So this should be M1 is equal to delta x1, 3L by 4 x3. M2, this should be x3 minus 2L by 3. Plus M3 x3 equal to 0. So what is the resultant? x3 should be equal to 3 M1 L by 4 minus 2 M2 L by 3 by M1 plus M2 plus M3. It all depends on now M1 and M2 relationship also. In what direction the Planck will shift. 3 by 4, 0.7, 2 by 3, 0.6. So again the M1, M2 will determine now. So what should be the ratio of M1 and M2 so that Planck should not shift? I think you can bring that ratio here now. 8 by 9. If M1 by M2 equal to 8 by 9, the displacement of Planck will be 0. If M1 by M2 is greater than 8 by 9, Planck will shift towards left. So like this, we can discuss about the conditions. If M1 by M2 is equal to 8 by 9, Planck not shift. Though persons moved. If M1 by M2 greater than 8 by 9, what about x3? x3 will be non-zero. Planck will shift towards right, towards left. Planck will. Now, x3, the interpretation of sign is very important. x3, if I get positive, what I should assume?
in the numerator, it should be minus 3m1 L by 4 plus 2m2 L by 3. Sir.
Any calculations I have to check it?
The sign, sir.
Yes, sir, fine.
Numerator, huh?
Yes, sir, numerator.
What should be the sign? Minus 3 ml. Huh?
Yes, sir, minus
Yes, sir.
3m1 L and plus 2m2.
Yeah, okay, fine. Yeah. Now m1 m1 by m2 equal to 8 by 9. Okay, that okay after solving. No? Next again, you try to look at this condition. If m1 by m2 is greater than 8 by 9, x will be non-zero. Planck in what action? If I get negative, Planck will shift towards left. x3 will be non-zero and will be negative. x3 not equal to 0, Planck will shift towards left. Or x3 negative also you put it. Because we assume anything towards right positive. If you get negative, it will shift towards right. If m1 by m2 less than 8 by 9. x3 non-zero, x3 positive. Planck will shift towards right. Okay, there's overall the basic idea. I think this is very systematic way, that one. All the unknown things you need to bother. The unknown things sign also you need to bother. Just the known things. What is the known thing? The displacement of person with respect to Planck. We know only that one. Here, look at this sign, negative. And look at this sign, it will be positive. Why the positive, negative? Anything towards right positive, towards left will be negative. The relative displacement or absolute displacement, anything it will be. So these are the plenty of numericals you do have in books. Almost around some 20 numericals are the related of different systems conditions will come. Initial velocities, if they're running, you can't apply this. If they're running with a velocity, then the Planck will have velocity of the Planck will come. Then from the velocity of Planck, you should calculate the displacement. Other method will be there. Now we are taking a situation. Initially they are at rest and they walk slowly on the Planck. So what is the assumptions if you want? Planck is initially at rest and the persons walk slowly on it. There's a condition. Okay, now you do have plenty of questions related to this. This analysis what I did. So I suggest you this formula you don't. There's a overall. The whole chapter just revolves around this idea. And again, I told you the first approach and the second approach. The idea of the first approach and second approach. If there is a friction between the Planck and the ground, what conditions will come? If the surface is rough. This must be rougher, then only the person can, as he's walking, friction will be like this. This is F1 and F1. So this frictional force, what it does now, M1. This frictional force, F1, what it does, will try to shift the Planck. With the Planck will shift or not, what happen? An external force is acting on the system. Okay, look at now. What is the net external force acting on system? This will be unknown, no? F2 is external force. So net external force will be non-zero. Tell me what will happen to delta axiom. Will be non-zero. Center of mass shifts towards right. And now you can, on what basis you are saying, sir? Because the center of mass all happen. Initially, the person in Planck are at rest. And the person starts walking. Let's assume that the friction F1 is greater than, it's a static friction, no? It can overcome that kinetic friction F2K. or F2 static or kinetic, irrespective of that, the plank will shift. Let even plank at rest or plank will shift. Net external force is acting on that one. And the center of mass, what happens? Will shift in the direction of net external force. So here, conclusion, what I can write, center of mass shift towards right. Reason for that, because F2 will become external. So what is the internal now? Now this will be internal. This F1 will become internal. This F2 will become external. External to man plank system. And what about F1? F1 will become internal to man plank.